If Tony Stark existed today, we could already build parts of the Iron Man suit, the AI assistant, the heads-up display, even the flying jetpack. But despite all of humanity's technology, there is one problem so difficult that it turns the entire idea into science fiction. And it isn't the part most people think. Most people assume the suit itself is impossible. It isn't! Modern fighter pilots already wear helmets that project information directly onto their visors. This means a pilot can see speed, altitude, navigation, and critical flight information without ever looking down at an instrument panel. In a strange way, Tony Stark's helmet display is one of the most realistic parts of the entire suit. The AI is becoming realistic too. When the first Iron Man film released in 2008, Jarvis felt like magic. Today, millions of people talk to AI systems every single day. Some can write software, some can design products, some can analyze images, some can even control robots. The idea of an AI co-pilot no longer sounds impossible. So if we already have AI, and we already have advanced displays, what's stopping us? This is where things start getting weird. In the movies, Iron Man accelerates like a missile. Sometimes he goes from stationary to hundreds of miles per hour in just a few seconds. The suit might survive that. Tony Stark probably wouldn't. Humans are surprisingly fragile when it comes to acceleration. Formula One drivers can briefly experience around 5 times the force of gravity while cornering. Fighter pilots can experience around 9 times the force of gravity before risking blackout. And even that requires years of training. Yet Iron Man regularly performs maneuvers that would likely subject his body to forces far beyond that. The suit surviving isn't enough. The human inside has to survive too. A real Iron Man suit wouldn't just need to fly. It would need to protect its pilot from physics itself. Then there's walking, which sounds simple, until you try to teach a robot how to do it. Humans spend years learning how to walk. As toddlers, we fall thousands of times. Eventually, our brains learn to balance automatically. A loose stone, a slippery floor, a small change in terrain. Your brain makes thousands of tiny corrections every minute without you ever noticing. Robots don't get that luxury. Every step has to be calculated. Every correction has to be calculated. Every movement has to be calculated. This is one reason why building humanoid robots is so difficult. Walking turns out to be far more complicated than most people realize. And Iron Man isn't just walking. He's running, jumping, landing, flying, fighting, all while wearing a machine that could weigh hundreds of kilograms. But none of those are the biggest problem. The real problem is energy. Imagine the suit flying. The thrusters need power, the motors need power, the computers need power, the sensors need power, the displays need power, the cooling systems need power. Everything needs power. And modern batteries simply don't store enough energy. A kilogram of jet fuel contains roughly 50 times more energy than a kilogram of modern lithium-ion batteries. 50 times! That's one reason commercial aircraft still rely on fuel instead of batteries, and Iron Man uses something far more demanding than a passenger aircraft. He flies vertically, accelerates rapidly, lifts enormous loads, and somehow powers a supercomputer at the same time. With today's technology, a battery capable of doing all that would likely become one of the heaviest parts of the entire machine. And that's where the nightmare begins, because bigger batteries mean more weight. More weight requires more thrust. More thrust requires more power. More power requires bigger batteries. And the cycle repeats, again and again. The machine becomes trapped in a loop. But let's pretend we somehow solved the battery problem. We're still not finished. Because energy creates heat. Your phone gets warm. Batteries get warm. Now imagine all of those systems packed tightly around a human body. A real Iron Man suit could become dangerously hot very quickly, which means it would need cooling systems, fans, liquid cooling, all of which add more weight, which requires more power, which creates more heat. And suddenly, we're trapped in the same cycle all over again. So how close are we? Closer than most people think. If we combine the best AI assistants, the best helmet displays, the best exoskeleton technology, and the best jetpacks available today, we could build something that vaguely resembles Iron Man. But it would be incredibly expensive, extremely heavy, difficult to control, potentially dangerous, and nowhere near as agile as the version we see in the movies. We can build pieces of Iron Man. We just can't build Iron Man. At least, not yet. So can we build the real thing? Not today. Probably not tomorrow. And maybe not for a very long time. Because Iron Man isn't one impossible invention. It's 10 extremely difficult inventions stacked on top of each other. Advanced robotics, artificial intelligence, human protection systems, flight, thermal management, miniaturized computers, and most importantly, energy storage. Until humanity discovers a fundamentally better way to store energy, Tony Stark will remain exactly where he belongs, somewhere between engineering and science fiction. For now.